All right, this screencast is kicking off Module 14. Lesson 1 is understanding polynomial expressions. So by the end of the lesson, you're going to know what a polynomial is and how you simplify them, etc. Okay, so let's start right here. A monomial, mono is meaning one. A monomial is an expression consisting of a number, a variable, or a product of numbers and variables that have whole number exponents. We have talked about terms before, but remember that a term, the terms of an expression are parts of the expression that you can separate by plus signs. We can kind of say plus or minus signs because remember minus is really just adding the negative. So a monomial cannot have more than one term, and it cannot have a variable in its denominator. So here are some examples of monomials. Here are some examples of things that do not qualify as monomials. Okay, so this is a number, so it qualifies as a monomial. This is a variable, so it qualifies as a monomial. This is a product of numbers and variables, right here, so it qualifies. This is the product of numbers and variables, and the variable is raised to a whole number exponent. Here, this is the product of numbers and variables, and you're looking at me going, product? It's divided by 4. Well, xy, 1/4 xy, 1/4 times xy is the same as xy over 4. So multiplying by a fourth is the same as dividing by 4. So this also qualifies as a monomial. All right, let's talk about why these do not qualify as monomials. This does not qualify because it has more than one term. Remember, a term can be separated by a plus or frankly a minus sign. Okay, so we have term and another term. So that's not a monomial because there are two terms. Here, this is not a monomial either because again, you have two terms. This is not a monomial because x to the negative 2 is really 1 over x squared, and you cannot have a variable in the denominator and have a monomial. Same thing here. You've got a number multiplied by x to the negative 1 power, but that really becomes 0.25 divided by x, and you cannot have a variable in the denominator. Over here, again, variable in the denominator. So these guys are not monomials, these guys are. Please keep all of this in mind as we go through several examples. Okay, I'm going to skip down just a little bit. I think it's just easiest to start here. First of all, does 5ab squared have a denominator? Well, no, not really, unless you consider the denominator to be 1. And usually the denominator of 1 is not written unless you're trying to make it look like a fraction. If possible, split into a product of numbers and variables. All right, so 5ab squared is really 5 times a times b squared. List the numbers and the variables. The numbers that we have in that term are 5. The variables that we have are a and b. Check the exponent of each variable. The exponent on a is 1, and we usually don't write exponents of 1, which is why you don't see it over here. And the exponent on b is 2. So the exponent of the variables in 5ab squared are all whole numbers. Therefore, 5ab squared is a monomial. Is 5 over k squared a monomial? No. The reason why it's not a monomial is because it has a variable in the denominator. Denominator. Sorry, learn how to spell. Okay, join me on page 674. Okay, so they've got some items, terms down the column, and they want to know yes or no, is it a monomial, and explain why or why not. So we already did this one from the previous page. We said yes, it's a monomial because it's the product of a number and variables, and the variables have exponents raised to whole number powers. All right, is this a monomial? Yes. It is variables, or a variable, raised to a whole number exponent. Okay, my up arrow just means raised. Okay. What about the square root of y? Well, the square root of y is not a monomial because really the square root of y is y to the 1/2 power. So this variable is not raised to a whole number exponent. 2 squared. Well, 2 squared is really just a number, which is 4. And is a number a monomial? Yes. It's a number. 5 over k squared. That's another one from the previous page. We said no, it's not a monomial because it has a variable in the denominator. 5x plus 7. Is it a monomial? No. More than one term. What are the terms? You have 5x, a positive 5x, and you have a positive 7. You have 2 terms. Okay, so you don't have a single term, so it's not a monomial. Again, here you have 2 terms, x squared and 4ab. It's not a monomial because you have more than one term. K squared divided by 4. Is it a monomial? Yes. It's the same as saying 0.25 k squared. Okay? You have numbers and variables raised to a whole number exponent. Okay? All right, scoot down a little bit. Let's look at the discussion questions. Explain why 6 to the 1/3 is a monomial. Well, 6 to the 1/3 would be the cube root, the cube root of 16, and that's like, I don't know, 2.51 something. It's an irrational number, but it's a number, and a number qualifies as a monomial. So yes, it's a number. But why is x to the 1/3 not a monomial? Because it is a variable raised to a power that's not a whole number. Okay. So the cube root of 16 is cube root of 16, or 16 to the 1/3. Yes, it's a monomial, but x to the 1/3 is not. Okay. Is x to the 0 a monomial? Well, justify your answer in 2 ways. Well, I can say that x to the 0 is a variable raised to a whole number, whole number exponent, which is 0. 0 is still a whole number. I can also say, yes, it's a monomial because x to the 0 is going to give me 1, and 1 is a number. Okay?